Hi everyone, welcome to Spacy Masterclass tutorial. In previous tutorial we have learned introduction of a Spacy and tokenization using a Spacy. In this lecture we are going to study parts of speech tagging and dependency parsing. After tokenization in a Spacy actually parse and tag these components. In a previous tutorial you learned this. After once we pass this document or text data, it does the tokenization here. After this tokenization, tagging and the parsing happens, and thereafter NER happens. This is the default pipeline of the Spacy. If you have not watched previous video, you can get the link in video description. Go and watch that video there. All right. Thereafter doing this parsing and the tagging, this NER happens. But you know how these parts of speech tagging and dependency parsing happens here. There is a binary model in a Spacy which is pre-trained model. Okay, that pre-trained model is these models like these EN-Core Wave SM. This one is the pre-trained model which we download from the Spacy. And there is medium and the large model is as well available at the Spacy there. You can download these English language model to do parts of speech tagging and the dependency parsing. So what are the attributes you can access from the parts of speech? Actually, you can get the list from here itself. You just open this here. You get all these documents you can access from this doc object which is produced by this Spacy. Once a Spacy runs, then it produces this doc object. This doc object have these attributes you can access from there. All right. Now do you see here there are two duplicate names, seems like, because there is a name and then the same name with the underscore. Okay, so this name is actually a hash value. Like every other NLP model does these hashing there to make it faster and save some memory. Spacy works in that way as well. All the tokens, all these tokens are stored in the hash value. If you want to access the actual value from the Spacy, then you have to put there the underscore value there. All right, so enough of the talking. Let's go ahead and see how these parts of speech tagging and the dependency parsing happens here. Well, as usual, you need to install your Spacy with these three commands. You install a Spacy, its setup tools, Spacy, and then you download this English language model there. Thereafter, you do here import Spacy. All right, so this imports Spacy, and thereafter we are gonna create here an NLP object here. Then I say here NLP is equal to Spacy dot load, and then I'm gonna load this particular model. All right, so this one gonna load that model. Once this model is loaded, this one is a language model. Now we are gonna get the document. So our original text data is this one. People is looking at buying UK startup for $1 billion. This one is our text data. Now we are going to get the object from the NLP language. We pass our text data in this. All right, now you see, as previously in our first video we got here this linguistic annotation. In that linguistic annotation we accessed those attributes which we were seeing here. These attributes we access with the underscore. There are many attributes are here, maybe perhaps 50-60 total attributes are there. So these attributes you can access from that doc object, this doc object which we just produced here. All right, in this doc object. So this object is actually the tokenized here. There are the multiple tokens here, and if you want to access the objects for each of those tokens, you have to iterate this doc object. All right, so we want to also print this doc object in a nice and tabular format. So what I'm going to do here, I'm going to install a beautiful table here. So I need to write here pip install beautiful table. All right, just install this. Once it will install, I'm just gonna clear these outputs to save some space. All right, then I'm gonna do here from beautiful table import beautiful table. All right, so this table is imported here, and then I create here table is equal to a beautiful table. This one is an object of the beautiful table. All right, once all these happen, now it is time to iterate this doc object to get these components. That's mean from this text data we can get all these tagging or the text documents from there. All right, I'm just gonna add few cell here, just add code there. Then what I'm gonna do here, I'm gonna add here this table dot columns dot header. So this one is gonna put the header of table there in the column value. There I say first is gonna be a text. Thereafter, I'm gonna put here parts of speech, POS, tag, and dependency. POS. Thereafter we had this tagging value there, and then we had this dependency parsing there. There are other attributes as well, like the shape attributes. I'll show you in that attribute list what is this. And we are also going to access from here is alpha attribute. And thereafter, this is alpha says that whether a particular token is alpha value or is it numeric or alphanumeric there. All right, so that says that is alpha. And at the same time, we can also get here is stop word. That's when is stop means if a particular value is a stop words or not, like these are the stop words there. All right, so that's how I got this table column dot header, and then I can simply go for token in doc, because this doc object was actually tokenized into a multiple tokens. If you see this previous example in last tutorial, let's say this was the text data. Let's say if this was the text data, it was tokenized here into a multiple tokens, right? These are the multiple tokens. So the same thing happened here. This particular data is analyzed into a multiple tokens, and those tokens we are going to access by iterating this doc object. All right, then I say here table dot rows dot append. All right, so we are gonna append these values into a rows so that we can show it into a tabular format there. I say token dot text, that's the original document here, the original text data. Thereafter I say here token dot POS underscore, that's the parts of speech here. All right, then I say here the token dot tag underscore. Then I again say here a token dot dependency underscore, that's the dependency parsing there. Then I get here token dot shape. Then again I need to put here underscore so that I can get the text value. Then again token dot is alpha. All right, so is alpha actually don't need here any underscore because it's already a numeric value. Ones and zeros are true and false, you can say like that. So there is no text data, so you can consider that it is in the same format. There is no need to put there underscore. And similarly there token dot is stop. Now one thing you always need to remember, the number of headers here you have to match these number of fields here inside, otherwise it will throw the error. So whatever the header you put here, you have to put same number of values here, otherwise you cannot keep larger or lesser rows column than the all other rows. All right, so I just run this. Thereafter I'm just gonna print this particular table here. All right, now you see this is a very beautiful table printed here, and overall text data which we had, that was Apple is looking at buying UK startup for $1 billion. So this text data is here. Apple is looking at buying UK startup for $1 billion. The parts of speech says that this one is the proper noun, auxiliary, and now there is the verb, and then the verb, proper noun, all these things. Although the sum of names actually I don't remember. I'm just some of these names I think I'm missing. You can get these names from here. Universal dependency POS. You just need to open this link from here. You get all those values which we are missing here, right? I think it was what was that, ADP, that is here, this one, right? You can get there. This one is at position here, is a cover term for the prepositions and the post positions. This one, ADP. All right. Although if you want to know at the shorter format here, you can just get it from here, like add position, all the I mean to say that actual name of the shorter format is here. This proper noun, punctuations, all these here. All right. Then the tagging says that here how these words are actually dependent on each other there. If you want to get the details of these tagging, you can get these details from this link here. I'm just gonna paste this link there and here as well. All right, let me just put this link here. All right, so there we have this whole tagging, a detailed tagging. I'm just gonna just zoom it. Now you see there we have this tagging is actually a detailed parts of speech explanation there. That means how this parts of speech tagging works there. So like we have for this Apple, we have NNP. That's when now you see here NNP is noun. This one is a proper singular noun here, NNP, and the example of a proper singular noun is like Germany, God, Alice, all these are proper singular noun here. And similarly, we have here, VBZ. VBZ is somewhere here. You see, this one is the verb, third person, singular present. Now it's like see things or something like that. Now you see there, there is this one, and then we have VBG there, right? That's mean we have this one. Verb, gerund or present participle, like thinking is fun or something like that, right? Here we have looking, and there is the thinking or something like that. This one is interjection here. You see there, IN, that's that one is here. This one is conjunction actually. So there you have a conjunction like off, on, before, unless, in, all those. So this one gives you a detail, exact parts of speech tagging. And this one says that as the overall parts of speech, and this one tags a particular form of the parts of speech there. All right. And then dependency, this one says that how these words are related to each other, right? So dependency is actually this syntactic dependency is a relation between the two words in the sentence in which one word is governing words, another one is the depending words. So what happens here, it says that the root, that's mean it says that this one is a word which is actually making some action here. This one is the root word. All right. And this one is a noun there, a subjective noun you can say. So this apple is subjective noun there, and the action is being done like looking. All right. The action is being done as the looking, and rest of other dependency here. We will take another lecture where I'll explain you how these dependency are work together, how one words are dependent on the another words. All right. So the next lecture maybe will be based on these dependency parsing specifically there. All right. So thereafter we have this, the shape is there. So in this token you have a shape as well. Maybe we can search this. All right. So their shape is, it says that transform the tokens string to show orthographic features. All right. Alphabetic characters are replaced with either small x or capital X. If number is in a capital format, that will be replaced with the capital X. If it is in a small format, then it will be replaced with the small x there. and if it is number, then it will be replaced with D there, a small word of the D. Now you see there the same thing is happening. This one is form of 5 word. Now you 5 character. Now you see the shape says that total 5 X are there. One capital X says that the first character was in a capital letter. Here all character and the rest of other characters was in a small letter, and there we have a capital letter. Then again, this one is the currency. The parts of speech tagging for this currency is a symbol there. And then of course this one is the number there, and this one is also represented as a number there. Alright, and this number is represented as a D in the form of shape. And this one says that whether this particular token is completely alpha token or not. So it says that yes, this one is the alpha, all these are alpha, but this one is not the alpha token, because there is this one is kind of the mix of the tokens with the dot and this one. So there is the special characters inside that. Then of course these are the alpha tokens there, but these two are definitely not the alpha tokens. Similarly, it says that is it a stop word? So one means yes, it is a stop words. In English language there are words which are quite repeatable words. Those are stop words, like is, for, at. All these are stop words there. This one is the at. I mean to say that the words which doesn't make much sense, and which gets repeated multiple times, those are placed as the stop words in the English. You can simply search here stop words in English language. So you will get here these, you can open any link actually from here, whatever the link comes first to you, you can open, no, this is not there. Maybe here you can open. Does it have? No, it don't have. I'm sorry. Yep. Let's see here if it has. All right. So NLTK have these stop words. All right. So these stop words are repeated, quite often. So the words which are repeated quite often in literature, those are considered as a stop words. So yes, of course, this one is repeated quite often in literature, so it is considered as a stop words. This one is also a stop words there. All right. So that's how you can do the parts of speech tagging. And in the coming lectures, I'll be talking more about the dependency parsing, how one words are related to another words. I'll be showing you how these root and the subjective nouns are correlated to each other, and other than that, like preposition and other dependencies, other tokens are dependent to each other. Thanks for watching this video. Stay tuned for the next one.